As part of my problem series, in this video, I will be calculating the voltage V0 using loop analysis. Once I am finished with a series of problems, I will be posting them in my StanStore at this web address. Our task for today's problem is to find V0 in this network using loop analysis. Since the network has two loops or two meshes, we will need two equations to determine the currents. Note that since I2 goes directly through the current source, I2 must equal 2 at 0 degree amps. Therefore, one of our two equations is already solved, and that is I2 is equal to 2 at 0 degrees. If we now apply Kirchhoff's voltage law to the loop number 1, we obtain minus 12 plus I1 through and times the two impedances 2 minus J1. And since for the next two impedances the currents will be the sum of I1 minus I2, so we must add the product of I1 minus I2 times 4 plus J2, which is all equal to 0. We now have two equations which will yield the mathematical solution for the two currents. Substituting for I2 from the first equation into the second now leaves us with one equation and one unknown, I1. Removing the brackets yields minus 12 plus 2I1 minus J I1 plus 4I1 minus 8 plus J2I1 minus J4, all equal to 0. I have colored the I1 terms for clarity, and collecting like terms moving through the whole numbers to the right and the equation and keeping the variables on the left hand side, we get I1 times the quantity 6 plus J1 equal to 20 plus J4. Cross multiplying, which is the same as dividing both sides of the equation by 6 plus J1, we get I1 is equal to the quantity 20 plus J4 divided by 6 plus J1, or I1 is equal to 3.35 at 1.85 degree amps, or 3.3 plus J at 0.1 amps in both polar and rectangular coordinates. The voltage drop across the 4K ohm is V0, which is equal to 4 times the quantity I1 minus I2. Substituting our known values for the two currents, V0 is 4 times I1, which we know is 3.35 at 1.85 degrees, minus I2, which we know is 2 at 0 degrees. Converting the rectangular coordinates in order to perform the addition, we get 4 times 3.3 at J 0.1 minus 2 at 0 degrees. In rectangular coordinates, it's just 2 at plus J00. Adding the two currents results in 4 times the quantity 1.3 at J 0.1. Finalizing the arithmetic, the voltage is equal to 5.2 plus J 0.4 volts and 5.42 at 4.57 degree volts in both polar and rectangular coordinates. I want to introduce you to another product that's out there that is worthy of paying attention to, the 𝐃𝐈𝐒𝐂𝐋 F2000 generator. To find out more about this battery generator and to keep up to date on any sales or discounts that are available, simply go to the Anchor site at this web address. And by using this web address, you can get $800 off the original price, or just browse through the various options on this site. There is no charge for just looking, but you might find something that is available at a discounted price at this particular time. And remember, this video has been brought to you by PSPT, where you will find electrical training videos when you go to this web address, which will also give you a free copy of my 50-page crib sheets that you can use while viewing any of my courses, or just keep it handy during your everyday work.